And we're back with quadratics. So we are still talking about quadratics, but we're going to look and see. This is a pretty good application part here. Whenever you have, I guess when you kick, throw, whatever, a ball up into the air, it makes a parabola when it goes up into the air, but also at the same time, as time goes on, the height of the ball reaches a maximum and comes back down, much like a parabola. So let's look at this first kind of situation here. We have an archer that shoots an arrow into the air. For those of you that have taken archery before, because we're going to know how that works. It says the equation that describes the path of the arrow is h equals, so h is the height, and t is the time in seconds. So h equals 17t minus 5t squared. To my knowledge right now, I don't think you would ever have to come up with that. I think that's going to be given to you. I could be wrong, but that's kind of sort of where I think. It says where h is the height in meters and t is the time in seconds. All right, so how high is the arrow after 2 seconds? This is asking basically what is h when t is 2. So I have an equation. I can replace t with 2. So 17 times 2 minus 5 times 2 squared. So I'm going to put that straight into my calculator just like you see it and find out the height. So I put that in there and my height is going to be 14 meters. So at the time 2, I can find how high it was at. It says, when will the arrow be 10 meters high? So I'm wanting this time to find out what t is when h is 10. So I'm going to go here and plug in 10 for h, 17t minus 5t squared. So here, there's my equation. I'm basically wanting to know t. I'm solving for t. Should look familiar now in that I'm going to get 0 on one side. I'm going to rewrite mine in standard form. I don't think that there are factors of 50 that, or positive 50 that can give me to 17. So I'll have to do this through a quadratic formula. So x is equal to negative 17 plus or minus the square root of 17 squared minus 4 times negative 5 times negative 10. A and C have the same sign. Let's just make sure. Divided by 2 times negative 5. So let's look at our discriminant to see if we're going to have a solution. I do. So I'm left with x is equal to negative 17 plus or minus the square root of 89 divided by negative 10. And then I have my two equations in here. And I'm just going to write my two solutions. So x is equal to and x is equal to. I'm just going to plug that in to my calculators, one with plus and one with minus. So I end up with 0.75 and 2.64. I gotta do some rounding there, might be 7.6. But anyway, so at both of those times, I wrote x. I guess I really should have wrote t. So t is equal to. So at time 0.75 seconds, so almost at a second, it's going to reach 10, and then it reaches up and starts coming down, and after 2.5 seconds, it reaches 10 again. It's going to reach it 2 places. Then it says, when will it come back to the ground? And it says when. So I want to know what time. Will h be 0? H is going to be 0 this time. So therefore, I have 0 is equal to 17t minus 5t squared. You can do the quadratic formula with this and c is equal to 0, or you can factor out t, and you're left with 17 minus 5t is equal to 0. Now you have two factors multiplied together that get you 0. So either t is equal to 0 or 17 minus 5t is equal to 0. And then solving over, I get t is going to be equal to 17 fifths. That might be a decent decimal. And since we just wrote our last one, as a decimal, I would probably go ahead and write it as 3.4. Either one, I'll take a fraction. It's just a little bit easier to see what that time really is at 3.4 seconds than 17 over 5 seconds. That's just me. So I know I kind of harped on write it as a fraction, write it as a fraction, write it as a fraction. Again, kind of have to take that in the context. All right, so these would be my two answers. And it finally says come back to the ground. I don't even know that I would use 0 because it started out on the ground, which is kind of sort of odd because if you think about it, an arrow doesn't get shot at. But that's what we're assuming. And then we have 3.4 seconds. So we're assuming that the arrow is actually shot from the exact ground, and after 3.4 seconds, it hits the ground. Okay, let's look at the next one. It says Chris Brown of the Houston Texans kicked off a ball on the outset of the game. The height of the ball can be modeled by this equation 17t minus 4t squared, where h represents the meters, height in meters, and then t is t seconds. All right, so it says how high is the ball? What is h whenever it is been in the air 3 seconds? So t is 3, h is what? This one's I think is easier because you don't have to do any of this necessarily solving, especially like quadratic formula. So then plugging that into your calculator, you get 15. So it is 15 meters in the air whenever it has been 3 seconds. When will the ball be 8 meters high? So at what time would the height be 8 meters? So I'm going to plug in 8 for h. So I have 8 is equal to 17t minus 4t squared. Again, I'd have to solve that. So I have to have 0 over here. So I have negative 4t squared plus 17t minus 8, moving 8 over. Quadratic formula here. I have t. I guess I'll write t. I don't know, on the last one I wrote x. But t is going to be equal to negative 17 plus or minus the square root of 17 squared minus 4 times negative 8, all divided by 2 times negative 4. So let's see when it will be 8. Let's look at the discriminant, right? So we got to look at that first. And so I have negative 17 plus or minus the square root of 161 divided by negative 8. And so now I'm going to get my two answers. So t, time, is going to be equal to, so we get t is equal to 0.54 seconds, and t is equal to 3.71 seconds. Again, it's going to hit 8 meters high twice. Then it says, when will it be 26 meters? So again, I'm going to have 26 is equal to 17t minus 4t squared. I have to move 27 over. 0 is equal to negative 4t squared plus 17t minus 26. So my formula, I'm going to come down here, t is equal to negative 17. It's going to look very similar to the one above, except that I'm going to have 26 for c, or negative 26 for c. So I have 17 squared minus 4 times negative 4 times negative 26. All divided by 2 times negative 4. So I'm going to do the discriminant first, remember, so that way I can see if I'm going to have a solution. And so my discriminant here, I end up with negative 17 plus or minus the square root of negative 127 divided by negative 8. And so when you can't find the square root of a negative number. So what does that mean in this? I mean, you can't write no answer. It means, because it says, when will it reach 26 meters high? It never will. It never reaches that height. It only reaches a certain point, starts coming down. It starts reaching that highest point at that vertex and then starts coming back down. It says, when will it come back to the ground? So again, ground, h is 0. So basically when h is 0, what is t? So 17t minus 4t squared. I can factor out a t. I'm left with 17 minus 4t. Two things multiplied together gives me 0. One of those two things have to be 0. So either t is equal to 0, or I have 17 minus 4t is equal to 0. So then t is equal to 17 over 4, or 4.25. So these are seconds. And then it's, again, it says come back to the ground. So I would say this is the only one. It started out on the ground. That's why time is 0. So at time 0, it was 0 height. But really, the only one that you want to deal with is 4.25. I won't be as picky with that as I was with, or if it had a negative. If it has a negative answer, that obviously would mean, you can't have negative time. So that one would be that would be kind of pulled out like with the length and the area of rectangle. So this is application of quadratics. Pretty involved. And lots of questions kind of being asked about the same scenario. Those I have for you, quadratic applications.